If you remember from last time when we were working with Python, executing statements on the console work only when the number of statements is very small. Once we have a large number of statements, it makes sense for us to put them in a script file and execute them together instead of running them one by one sequentially. So that's what we will do in the R script here. As I showed before, you can always click the file, do a new file, R script, and this will open up a script like this for you. Here, I will write the same script for finding out if the year is a leap year or not. But this time I'm using a if with a else block. If-else statements are conditional statements. So these statements help us or help the computer to make a decision. Whenever you see any question, any algorithm which requires you to make a decision, it's a if-else block. It will require an if-else block for that. And we call them conditionals. So now I have my entire program. If I run it, you can see that it says it's a leap year. If you run the program again with the year as 2021, it says it's not a leap year. Now, typically our scripts have a .r extension. You can run one line at a time by putting your cursor on that line and hitting the run button. So this will run the year 2020. And if you want to run the whole script together, just select it all using Ctrl+A and hit run. On a Mac, you have to do Command+A for that. The output will be in the console like this. And now that you know how to put R code in a file and run it, you can start taking advantage of existing R scripts and create your own scripts from here forward. Next, we will move to control structures. In R, we can comment out sections of the code using hash. As you can see here, it is highlighted in green, which shows that it won't be executed. So just like Python, R supports some basic control structures. In general, the control structures are of two types. One, the decision control structure or the conditionals, and two are the loop control structures. As the name suggests, if you want to decide if a statement or a set of statements is to be executed or not, based on some condition, you need a decision control structure or a condition. An example would be your if-else block, as we did in case of our leap year. But if you need the same set of statements to be executed iteratively or repeatedly as long as the decision condition remains true, you want loop control structure. Examples of loop control structures are for loop, do while loop, and so on. So let's look at a few examples. Say you would like to decide if the weather is okay for a bicycle trip based on the percentage of humidity present, and you want to write a code for this. So let's try writing that code here. We are assigning a value to humidity, and then we are checking. Once again, if you press tab after entering first few characters of the variable, it should pop up on its own. If humidity is less than 40, I'll say print perfect for the trip. Else if and I'll have to keep another condition here. If humidity is greater than 70, then I'll print not suitable for the trip. Just because, as logic suggests, it will be too humid and too warm for the trip. And if it's not less than 40, if it's between 40 and 70, then we may print out that it may or may not be suitable for the trip. And let's execute this control block. As you can see, I highlighted only the section which I want to execute, and I hit run. So as our humidity was 45, it says it may or may not be suitable for the trip. So as you can see in the above lines of code, there are three conditions based on which the decision is to be made here. Either humidity is less than 40, or humidity is greater than 70, or it's between 40 and 70. Next, let's take a look at similar examples of loop control structures. So what if you have accurate predictions of humidity for the next 7 days? So imagine the weather department gives you the value of humidity or the predicted value of humidity for the next 7 days of the week. So wouldn't it be good if you could just make some decision for all the 7 days? And you don't want to do it one day at a time. This is where the loop becomes very important, because we can iteratively execute the same block of statements for 7 times. Let's see how we can do it. To store the humidity percentages, we will create a vector. Vector is similar to a list in Python. We are putting all the values in this vector. Next, we are assigning count as 1. Notice that I'm not using equal to, but using the arrow operator here. So while my count is less than equals to 7, I will keep repeating this block of statements. I'm concatenating everything together, and then I'll execute the same block as I did here, but with a tiny bit of change. So I don't want to assign the initial value of humidity, which I will take out. And humidity is not a single variable now, it's a list. So every time I want to check the certain humidity percentage which is applicable for that particular day, and count keeps track of the day of the week. So in the beginning, I'll check humidity for day 1, then I'll check humidity for day 2, and so on. So I'll have to replace all the variables which said humidity with the value of the list. And in the end, we'll have to increment the count by 1, because the count won't increase on its own. So inside the loop, we will need to increment the value of count. If you look at the code here, we start with count equals to 1 and we'll continue till count is less than equals to 7. So we will keep repeating it for all the 7 days of the week. And every time I'm taking one value from the list here. So now as I notice here, I have one less value in the list. So I should have 7 values in this list. So each time it takes one value from the list. The value which it takes from here depends on the value of count. Let's execute this block of statements. You can see it has given us output for the entire week. Now this is what we have achieved using this while loop. We can achieve the same thing using a for loop as well. So let's try using the for loop. Now once again, for loop and while loop are very similar because both of them achieve one purpose. They help us repeat a block of statements. However, for loops are more beneficial if we know the number of times we are executing the block of statements. When we know what our endpoint is, when we know how many times we are going to execute the loop, people usually prefer using for loop. When we are not sure of the number of times we are executing the loop, we will be using while loop. Let's look at the same thing here. So I'll copy sections of the code from there. I'll copy the list and for count, there should be parentheses here for count in 1 to 7. So this means Count will vary from 1 to 7. And then the rest of the statement remains the same. Let's execute this block of statements together and see our output. Once again, you see the same output was produced by the for loop. So stop here for a moment and make sure that all the code above makes sense to you. Of course, the best way to ensure this is to actually try it all by yourself and make some changes to see if your logic works out the right way. So practice using some random examples on your own. Make sure that you understand how the while loop works, how the for loop works, how the if-else statement works. Recall our discussion on computational thinking from the beginning of this course. This will be a good place to practice it. Next, we will go into functions.